Here we go. We have a question, find the number of island. So you have given a grid of size n cross m consisting 0 means water and 1 means land. You need to find the number of island. The note here is a island is connected a directionally. So this is the sample input. So in this sample test case, there's only one island. So output is 1. Next we have this. So in this, 1 represent a island, then 2 represent second island. So for this input, output is 2. Next we have expected time and space complexity, then constraint, then again we have description, note, same input, same test case, then same second test case, same time and space complexity, then same constraint. So GFG is making a lot of mistake these days. I think the employee is not speeded. Anyways, let's try to build the approach. So I have taken this test case. In this, we will check for each and every cell. First, we encounter this cell. So this is 0, means already a water. We are not interested in that. Next, we have this 1. So there's a island, there's a land. So we don't know the length, the height and width of a island. So when we encounter a land, we just need to increment our answer first. So initially the answer is 0, we will increment our answer. Next we call our DFS function. In the DFS function, it is pretty clear that we have to go in 8 directions. So we are standing at ij position. If we go at top, so I minus 1 and j. If I try to go on bottom, we need to go I plus 1, then j. Then for right, it will be I and j plus 1. For left, it will be I and j minus 1. Then top left. For top left, it will be I minus 1 and j minus 1. For top right, it will be I minus 1 and j plus 1. For bottom right, it will be I plus 1 and j plus 1. For bottom left, it will be I plus 1 and j minus 1. So these are all 8 given directions. First we encounter this island. So when we encounter this island, we need to first change this 1 into a 0. So we will not again go to this cell. After changing this 1 into a 0, we try to go upwards, but this cell is not accessible. So we have a base case for this. If we are out of bound, we will just neglect it. Next we try to go on this cell. We have a water. So in the base case, we are out of bound, either we are out of bound or we are at a water. So this is a water, we are not interested in this, we will just return back. Next we try to go on this direction, on this cell. This is not accessible, this is not accessible, this is already water, this is already a water, already a water, already a water. So we have checked all the 8 directions. So we will just return back, and currently our answer is 1. Next we try to access this element. This is already a water, same applies for this, then these all elements. Next we access this element. So this is 1. So we first change this 1 into a 0. So after changing this 1 into a 0, I have missed one step, which is to increment our answer. Our answer is 2. Next we try to go upwards. It is already a water. This is out of bound, this is out of bound, this is already water, this is already water. Next we try to go on this direction. So this direction we have a 1, so we change it into a 0. Upwards, it is already a water. This is not accessible, this is not accessible, this is not accessible, this is water, this is water. We go here. So we just change this 1 into a 0. So we have 1. then we try to go upwards, it is already 0. We try to go here, we try to go here, 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 and here. Next we have 1, it will mark at 0. We try to go here, it will mark at 0. So what I mean to say is, if we encounter a land, we will change all the neighboring lands into a water, so we will not come back to the same land again. At this point, we have changed all the ones, and all the other cells either are out of bound or already a water. Answer is 2 now. So we try to access all the other elements. So we have reached till here. Next we try to reach this. These are all water, these are all water. So at the end our answer contains the number of island. In this case the value is 2, so we will just return the value 2. So that's how this algorithm will work. Let's try to code this. First we have nm and answer. Next we have a for loop, then again a for loop to select each and every cell. If we encounter a 1, means this is a land, we need to increment our answer. Next we will call our DFS function. This is our DFS function. So I am passing my current row, current column, nm and array. If we are out of bound, these 4 conditions are for out of bound, or we are the current cell is a water, so we will just return back. Next we are sure our current cell is a land, so we first convert into a water. Next we try to access all the neighbor cells. For this we have a separate function dir 0 1 0 minus 1. 0 minus 1 means current row, and j minus 1 means left hand side, so we are accessing left hand side neighbor. 0 1 means right hand side. Next 1 0 means our row increments, so we are going on bottommost side. So that's how we will access all the 8 directions. So we will select one by one. First we select this cell, so we try to go left hand side first. So for the current row and current column, for the current cells, I will increment the given direction. So for D0, we will pick this element and the current I. So it will change the current row to a new row. Same applies for the current row to a new current column to a new column. So that's how we will access all the neighboring cells. So after accessing all the neighboring cells, we have marked all the neighboring lands into a water. So we have a island, our answer incremented. So at the end just need to return our answer. So that's how this algorithm will work. Let's give it a try, and side by side let's talk about time and space complexity. First we have this function, it will work for n cross m. Next we have DFS function, it will work for n cross m. So inside all the nested loop we have a DFS function, but we are accessing a element only once. So the total time complexity is order of n cross m itself, not n square cross m square. No, we are yes, we have a DFS function inside the nested loop, but we are accessing a single element only once. So the total time complexity is order n cross m. So let's talk about space complexity. We have a grid, we are not using any space here. Inside that, if we include a stack space, we have a DFS function, but you can apply a BFS function. BFS function will work same, so I will not consider this stack space here. So the total space complexity is constant for this, because we have utilized the given input and changed the given input. It is not recommended. It is recommended to use a separate array to mark visited, either a cell is visited or not. So it is recommended to create a boolean array of the same n cross m size, but I am changing the given input. So for this code, the space complexity is constant. So we have met the expected space complexity not only once but twice. So this is a pretty common question based on recursion. I hope you have learned something new. Give this video a thumbs up, subscribe to this channel, and thank you all for watching.